I'm Tim Collins and I run the DigiVac company. The DigiVac company is a company focused on vacuum instrumentation and OEM electronic control. Nothing leaves our shop unless it's calibrated under real vacuum against a NIST standard. This is really important to our quality process. Tom Massey, our production manager and our calibration expert, is going to take you through our calibration process to give you a flavor of actually what goes on with calibration of vacuum instrumentation.
In order to calibrate our instruments, it takes 3 vacuum pumps. The first vacuum pump, outside behind the wall, is a rotary-driven oil-based pump. Our second pump is a small, rough vacuum oil-based pump. Our third pump is a high vacuum diffusion pump mounted underneath the table. This vacuum manifold contains 10 ports for calibrating customers' gauges, and we have a wide array of test standards. Now, when we say calibration, what do we mean? Calibration is taking an instrument's readings of known or good correct magnitude and applying those to another instrument of which we're unsure of the readings. DigiVac maintains several standards which are NIST traceable. My convectron gauge is an ultra-low vacuum gauge. It's good down to 10 to the negative third. We use this for readings between negative third and 1 torr. Our barometron gauge is used for readings from 1 torr up to atmosphere, generally presumed to be about 760 torr in any given day. And of course, our third instrument we use is a voltmeter. It's a common voltmeter, but it's been calibrated to a NIST traceable standard. Our 801W instrument is ready under vacuum. We can see it's given a good reading. It has 2 active set points. But of course, it's not properly calibrated compared to the reading on our convectron. Our first step, once the instrument is plugged in, warmed up, and stabilized, is to stop our vacuum system and purge the system using dry nitrogen to approximately 600 torr. The 600 torr reading will be indicated by our barometron when it reads 600.0. Now we can calibrate our 801W at any pressure higher than 500 torr. We certainly do not want to calibrate at atmosphere because atmospheric number changes on any given day. For good practice, we like to use 600. We'll approach that. 603 torr, acceptable place to take a reading. Using the span adjustment on our 801W, we're going to increase the potentiometer clockwise so our 801W reads right on the threshold of 600 torr. Barometron reads 602, 801W reads 600. That's a good start. Energize our roughing pump, pump our system down to the lowest achievable vacuum. Here at DigiVac, we can hit 10 to the negative third or 1 micron. Any pressure lower than 10 microns is acceptable for calibrating the bottom end of our 801W. Stop our roughing pump, open our diffusion pump. Watching our 375 convectron, we would like to see the pressure reach 1 millitorr or lower. Pressure is approaching 1 millitorr. We're currently at 1.4, 1.3. To make the zero adjustment on our 801W, we're going to find a potentiometer in the middle array. This is our zero adjust. And as we hover around 0 on our convectron, we're going to reduce the indicator reading on the 801W so it is on a threshold of 0 and 1. Clockwise increases the reading, counterclockwise decreases. We would like to sit right at 0. If the reading is stabilized, we can stop our vacuum system and observe readings on the way up, back up to atmosphere. Our convectron indicates approximately 30 millitorr, 29. We can introduce more dry nitrogen, 238 millitorr, 217 on the 801W, an acceptable reading. We'll look at some higher readings. 4.84 on our convectron, 4.80 on 801W. Using our barometron, our absolute pressure barometron, we observe a reading of 30.5. We're at 25. That is within spec in this instrument. Looking at our barometron, 155 torr, 100 torr, that's correct. 440 torr, 390. Still in spec, a little on the low side. We're going to take another reading at 600 torr. As I suspected, our readings have been a little low. we're going to make a secondary correction on our span using our Baratron indicating 600 torr, increase our gain by turning the atmospheric potentiometer clockwise. So we're right on the threshold of 600 torr. And now we're going to run backwards and take some readings decreasing vacuum. 600 torr, still 600. 219 torr on our Baratron, 200 torr on our 801W. 19.5 torr on our Baratron, 34 torr on the 801W. Looks like we'll make another correction down on the bottom end. To do that, we'll pump our system all the way back down to hard vacuum. Again, using our diffusion pump to achieve 1 millitorr or less. Wait for our system to stabilize, and we'll make a 0 correction. Convectron indicates 2.0. We would like to see 1 before we make an adjustment. Convectron indicates 1. DigiVac 801W indicates 1. We'll stop our system, and we'll take a few more readings, increasing pressure. Approximately 43 millitorr, 42. 2.26 torr, 2.69 torr. Acceptable. We'll go and look at our high end again and see how well we control up high. 560 torr, 540 torr. And my last check for calibration is to vent my system all the way to atmospheric pressure and make sure we're reading approximately 740 to 760 torr, and we are. This is our properly calibrated DigiVac 801W vacuum gauge.
Tom brought you through our calibration process and showed you how we calibrate our 801VW. And we feel that's very important to actually calibrate against a NIST standard under real vacuum to maintain our total quality of the instruments that we ship out the door. If you have any questions about calibration, vacuum instrumentation, vacuum level control, or some of the design work we do with OEM electronic control, please feel free to give us a call. We'd love to help.